Okay, so we're going to talk about literal equations. And literal equations are equations that have more than one variable and that require you to solve for a specific one. On the left side we have regular equations, and on the right side we have literal equations. You can tell the difference between them because this one has more than one variable. So we'll talk about what to do with that in just a second. But the best way to think about it is you're going to kind of follow the same rules that you would for the variable, like for solving a regular equation. So you're always trying to solve for something. So for example, on the left side we want to solve for x. So you're going to basically just get it by itself. So here it's 3x or 3 times x, so I'm going to actually divide by 3 and I'll get x equals 2. That one's pretty straightforward. We're going to use the same logic here for the right side. You're still solving for x, but if you notice there's no numbers. And sometimes in a literal equation there will be no numbers at all. And sometimes there will be, along with other variables. So I want to solve for x, but you have to look at what is going on with it right now. Right now it's px or p times x. So in order to free up my variable that I want, I'm going to divide both sides. Now I'm going to divide by p because that will allow me to cancel my p's out, because the opposite of multiplication is division, so these cancel out. And I will divide by p on the right side. And then my answer will be x equals m over p. And that's all the answer is. You can't give me a number solution because we don't have any numbers to begin with, but you can at least get the variable that you want to solve for by itself, and that's what we're trying to do. So now as we move down, on the left side, if this was 4x minus 8 equals 12, to get the variable by itself, I would add 8 to both sides. And it's important to show work here so that you can make sure you have a good job of record keeping so that you don't miss anything, so that you don't add something that shouldn't be added. We're going to have 4x equals 12 plus 8 is 20. And then you're going to divide both sides by 4. The 4's will cancel, right, because it's 4 times x, so dividing by 4 will cancel out. And you'll get x equals 5. Over here is a similar idea. Now, whenever I am going to solve for something, I look at where it is, and I'm going to just box it. I'm boxing it right now so that I don't forget. I see that there's a 4 in front of my x. It's 4 times x. So at one point, usually at the very end, I will divide by 4 to finally free up my variable that I'm trying to solve for, which is x. But in the meantime, I need to get it by itself. I need to get that 4x by itself. So I'm going to add y to both sides so that the minus y and the adding y, the plus y, will cancel. And I'm left with 4x equals. Now you can't actually add these two terms because they're not like terms. And we can't do any typical number math because there's no numbers. I don't know what these letters stand for. So the only thing that I can do that's mathematically correct is I can rewrite it as k plus y, which is really just a rewriting of what we have over here. And then finally, now I can finally address this 4x. I want x by itself, and that's when you're done. You have x by itself, so I have one more step to do. This is 4 times x, so the opposite of that is to divide by 4. I'm going to have to divide everything by 4. These will cancel, and I'm left with x equals k plus y over 4. Okay, so we're going to go on here, and if you look, now the goal is to solve for m. This is a regular equation, right? We can actually solve for m. Now I have two m's here. I have a minus m or a negative m, and I have 1m all the way on the right by itself. Now, since this m is already alone, there is no added stuff right after it, what I'm going to do is I'm actually going to add this m to both sides so that this cancels out, and I'm left with 6 equals m plus m is 2m, and then I'm going to free up my variable by dividing by 2 because it's 2 times m, so I'll divide by 2, that cancels out, and I do the same thing to both sides, so it's 3 equals m. Okay, so on the right side over here on this literal equation, what we're going to do is we are going to solve for m, just like in the other one. We're going to add m to both sides. Then we'll have z equals 2m, and now the goal is to get m by itself, so 2m isn't going to cut it. This is 2 times m, and so we're going to divide both sides by 2 so that we can really free up our variable, and so we'll get z over 2 equals m, and that's the best that you can do, right? It's a fraction. It's not the prettiest answer, but it's an answer. It does solve for m, which means that m is by itself, and so that's how you do literal equations. Try the other problems on the other pages and see if you can figure that out. Alright, thanks for tuning in.